Good afternoon, Muhammad. Okay, please.
Hello, everyone. Good afternoon.
Good afternoon, everyone.
Good afternoon, Idris.
Good afternoon.
Good afternoon, everyone.
I suggest, like we've been doing, let's just wait for like a few more minutes. As we are like participants right now, so like just wait a little
Okay.
for us to join. Okay, I think we can just start. Whoever joins us, joins
Okay,
us.
thank you. I'll try and share my screen.
All right.
Please confirm you can see my screen.
Yes, we can.
Okay. Okay, so my understanding is this is the first time we're treating what if analysis. So it's going to be like a walkthrough, I guess. But I will try as much as possible to provide use cases for how you could apply what if analysis in real business settings. So what if analysis has, when you check the Excel model for what if analysis, there are three of them. There is the goal seek and the data table, as well as the scenario manager, I should say. So I will start with the goal seek, and then I'll move to the data table and scenario manager. One thing I didn't want to do is have an already created Excel so that it will create some level of confusion. So we will build up as we go from here for the examples. Please let me know if that's okay.
Yeah, it's fine. It's fine.
Thank you. Okay, so I'm just trying to give an hypothetical scenario of someone who currently earns an income of, let's say, $5,000, and then from that income, the person is expecting to seek jobs or get an increase in salary in the current job, but the percentage is not determined. So we could percentage increase. So we could just say maybe 5% for now. And then from their monthly salary, they probably pay tithes. So let's say 10%. And then they also have black tax of, let's say, maybe $2,000 per month. And then their own personal costs of, let's say 50%. So let's say 50%, 20% of the cost, sorry. So, and this individual is looking to take a big project at the end of the year that would cost $40,000. So the person is thinking, what percentage increase in salary from what I currently earn would be such that at the end of the year, I can have $40,000 in net earnings, and then they could simply quickly go seek to see what that is, and then that could improve whatever they have in negotiation. So if we put it all together and just say, we could put it all together as, okay, let's say January, then we could drag to December. And then they have, so let me move this down a little bit. And then income. So the person is expecting some percentage on that 5,000, which is what we have here. So at least that's the hypothetical scenario that we are painting at the moment. And they have the type.
So let me understand the hypothetical scenario. You're saying that the person earns $5,000 and she's going to have an increase of 5% every month.
No. So we are saying that the person is looking to seek jobs or get an increase in their current job. However, that percentage is not determined. So this is 5%. So currently they earn $5,000. So
okay.
However, this person needs, expected, let me put it here, needs to have saved $40,000 at the end of the year.
So the 5% is an assumption.
It's an assumption for now. So that's what probably we're going to go seek on to arrive at 40,000. So I'm just trying to paint a typical scenario that we could use as a use case in this case. So we're saying that the person pays tithes, of 10% of that amount. Considering that tithe is an outflow, so I'm putting it as negative in this case. And they also have black tax, which is fixed at $2,000. So that's not negotiable, unfortunately. And then so we're just assuming that the amounts are straight and that nothing is happening to the amounts. And then their personal cost, which is at 20%. So their personal costs can move as we get, and it's also an outflow. So I'll just put that in negative as well. So they could decide to inconvenience themselves if they want to. So we could then say net earnings to be the sum of all of this. So, and at the end of the year, let's see what they are here saved. So at the end of the year, he has $20,000, and it needs $40,000. So it could simply go seek on the percentage increase, keeping it as the only variable that it could move, to see what percentage increase they have on what they currently earn at $5,000. That would give $40,000. So, and that's a very simplistic use case for GoSeek. And to do that, it just needs to go to data and what if analysis, and then GoSeek. And is going to have to then select the cell, which is this amount, is what he wants to be $40,000 by changing the percentage here. Effectively, he would need 52% increase in salary to arrive at that amount. So that's the use case, right? So it is either going to abandon the project or at least get 52% increase. So that's one use case.
Sorry. I didn't get that. Could you just?
Okay, yes. So and another thing I'll try to do is I'm going to walk through it with my mouse, but I would also try to show how we use keyboard shortcuts to make it sleeker. So what we're saying is let's return this at 5%. At 5%, the net earnings, the full year net earnings, is $20,000. But they need $40,000. This is the amount that is needed. I'll put it in blue.
Sorry. Can you also work with the personal cost, or you just have to work with one variable?
No, we can work with that. So where we get to data table, we would then move a lot of the other variables. So we could decide to say he decided not to be so religious and doesn't want to pay time, or he wants to pay 5% instead of 10%.
Okay.
We could say he can decide to cut the black tax. So we're going to move all of that. And when we get to the data tables, we're going to show how you could have move more than one variable at the same time to say, okay, if I get this percentage increase up and reduce my cost by this percentage, how do I get to that? So we're going to look at one-way data table, two-way data table, and there are so many scenarios. So this is the personal scenario for this hypothetical person. I'm going to also paint another example that you could use data table. For example, if you're trying to simulate, if you want to invest in Tesla stock, for example, or maybe a Nigerian stock, and you want to simulate a couple of experiments, you want to use Monte Carlo simulation and how you could apply data table to see what is probability of. So we're going to get there. I'm just trying to take it systematically slower, and then we can go for that. So again, we want to get $40,000 here. We'll just go to data, what if analysis, and GoSeek. So the question is set cell. So he needs to set a particular cell, which is the $20,000. He wants to go seek that to $40,000 by moving a particular percentage. So you could choose to move 20%. You could choose to move the black tax, but in this case, we're just using one variable to explain GoSig. So we're saying, okay, if you move the percentage increase, that's the most convenient way for a person's thinking that, okay, I know I can't inconvenience myself, and I know that my family's at home, I can't reduce black tax, and I have to be religious. So maybe I can also to get additional increase in salary. So that's the first thing they would think about, and that's exactly why we're using this example. Just click on that. So it's going to be 52% increase effectively. I canceled it because I wanted to show. So if we're going to use keyboard shortcuts, it's just going to be Alt A W G, and the same thing. So once as you click
Wait.
on.
What sorcery did you just do just now? Also what?
Alt AWG.
Alt AWG.
Yes.
Okay.
And then you do the same.
What's that for, please? The Alt AWG.
So if instead of you to go from, okay, let me try and make my Excel a bit friendly, sorry. So instead of you to move from, to go to data and then come down here and then click on this, which is the ideal way. If you want to make, if you're actually working on multiple simulations or it's an everyday thing, oftentimes, I, for example, don't use mouse when I work. I work with a keyboard. So I just know my way around shortcuts as opposed to moving around with the mouse like I'm doing right now. So I'm just saying, if you want to use keyboard shortcuts, you could do it that way. So you just do Alt AWG and 5%.
Okay,
40,000.
W for what? G for go. Okay.
Yeah, 5%. And then you have to do the same thing and just press OK. We're done. So that's one use case. So, and that's pretty much how you could use GoSig. The application is for one variable. If you want to switch one variable to achieve your end goal, so one variable only. So, but what if you want to see multiple scenarios? You cannot. GoSig will become one row because you have to run GoSig for every scenario and then note your numbers. So that's why they then invented data table. And data table is also the same thing. You just need to prepare it. So it's going to create a table for you that shows different scenarios that you need in this case. 1 second, please. So, yeah.
Hello,
Okay,
is it just me?
Yes, sorry, I was using the second screen and then the power went off, so I just got back in. Okay. So
okay.
Yeah. So. Okay, thank you. So, if we wanted, let's return back to a 5%, and then decide to use a data table. So there are two ways. So you could have a one-way data table and a two-way data table. A one-way data table means that you are only moving one variable, but you are seeing several percentages. So let's decide that we want to see we want to move the personal cost now. Let's assume that the fixed cost is fixed for now. Sorry, the percentage cost is fixed, but we want to move this personal cost. We want to see what percentage tolerance does he have that would still allow him to get the 40,000 if possible, assuming that 5,000 is free. 5% is fixed. So we could build a data table, a one-way data table to do so. So we can have the first thing you just do is put the percentages here. So because you can only go down from here on this personal cost. So let me just put it, let me say personal cost. So we could just have incremental reduction in that. So let's say 1% of each. Then let's drag it down to, let's say 10%. You know that okay, you cannot go below 10%. I want to see what the effect is on for every reduction on net earnings. So on the right here, you can just select the cost, and then you can then select everything this way, and go to what if analysis again. Now this time,
so basically what they're trying to sorry. So basically what they're trying to find out now is for every 1% reduction in cost, Like what will be
exactly. What is his net earnings? What is the impact of every 1% in cost? And that's what data tables allow you to do. You see the scenarios all at once without having to go all the time. For GoSync, you can only see one scenario at a time. You plug it in, and that's it. So for data tables, you could do one scenario, but you could see several sensitivities of that scenario. So that's exactly what we're trying to do. So data table, because we are on the column, right? We have selected, the variables are listed in a single column, column B. We will not put anything on the row. We are just going to leave it. But on the column input cell, we're then going to select that percentage, that personal cost that we want to move. And we say, okay. And you see,
this is the part that used to confuse me. Like, why did you leave that first one empty?
Because this, yes, we would get to the point where you would not leave it empty. And we would also show this same thing where you would not leave it empty as well. So the reason why you left it empty is because you are only doing a one-way data table. So
Please, can you do it again?
Yes, I will, definitely. And we would have another example that is different from this, where we would do proper simulation, and then we can then get the feel for it. So we are doing one-way data table. There are two-way data tables as well, which means that you are going to have to select the row and the column. Now, for this case, why we did not select the row is that the percentage sensitivities, this percentage here, they are all in one column. Okay, they are all in a column. So you have to put it. You want the result in a column, in a vertical form, and not on the row. So, and that is why we are leaving the row and selecting the column. So I could do the same here as well. Let me try and do it here on this side. And let me transpose this and do the same as well. Select 20,000. And this time around, I'll do my data table. The shortcut is AWT. So that's the way it's a table. And this time around, I'm just going to select the row and I'll leave the column. And then I'll say have the same thing. Should I take that again?
Okay, so okay, yeah.
So that's the reason. So because now my results.
So she said you take it again, no? She said she
yes,
take
I
it
will.
again, no?
I will. Okay. So because the result is in one row, and that's why I have to select the row and leave the column blank. Because I want the result in one column, and that's why I selected the column and left the row. So when you are doing two-way data table, it is critical. It is important that you know what you want, what is on your row and what is on your column.
So if it's two ways, you have to fill both the row and the column.
Yes.
Okay.
Yes, we will do that as well now. So let's redo this so that it's clear. So for I one way, this is for the column, Alt AWT, and I leave my row empty, and I come and select the personal cost, and I go. At times it doesn't change figures because your calculation option in the formulas might not allow it to. So at times, most of the time, your Excel is usually in this form. In fact, it's better if you are running a lot of simulation so that your Excel will not just continuously rule to leave it here. What it means is that if I do this one now, it will not change the numbers. So this one is going to be row. So you see that it's not changing until I come and say, make my calculation option automatic. There's a shortcut for that as well. So I could just, so it's going to be Alt MXA if you want it. Alt MXA, and it rules. And if you want to take it back to accept data table, is Alt MXE. So that way, so when you're running simulations and when you're running big, so for me, my daily activity, I do a lot of this sensitivity analysis, and the scenarios are quite very huge. So if you leave it automatic before you get to the end of your simulation, your Excel might crash. So you put it at that. So I'm very good at switching between just give me the result, don't do the simulation there until I get to the end. So when I get to the end, I'll then press Ctrl S I will check that my computer's fan is not ruling, so it means that it's not hot, and I will now open it. And I'll just walk away and come back and do it. That's pretty much how you do it. So we are going to see a two-way data table. So I'll leave this one here and just, so for a two-way data table, you are going to have two variables. So let's now assume that still, as you can see, it's still not going to get to $40,000 as he expected. And he knows that 52% increase in salary might not be feasible. So he has to play with the salary and the personal cost to see if he can get the $40,000. So to do that, it's going to have to do a two-way data table. So I'm just going to put it here, two-way. So we could decide to choose what we want to be on the row and on the column. So for us, we can decide to put this one on the row, which is the personal cost. Let me put that percentage. And then we put the increase in salary. So we can have it increase in 5% or how we want, so just 5%. Let's say to 40%. So it is at the intersection here that you are then going to select the amount, this one. Okay, once you do that, recall that we also selected that amount in this place and in this place as well. So it's going to be at the intersection, and then you're then going to select it like this, the same way data table AWT. Now, your row would then be what you have here, right? Which is the personal cost, and then your column would be what you have here, which is the percentage increase, and then you go. So and as we do that, okay, so you start seeing that I will take that, but you see that it's becoming quite feasible for him to earn 40,000 by combination of the two. So we could just
13%.
Yeah, we could just quick simply
40.
use maybe anything. Let's use this. So we could see that it's going to get to, if he wants to earn 40,000, you can get 10%, you can get to 35% increase in pay and reduce his personal cost to 10%, which is quite very extreme. You could also get 40% increase and still be at 13%. So, and you could have multiple, you could even concatenate scenarios, actually, if you want to, but let's leave that for now. So I'll take this again. So just so it's clear. Your row, AWT, your row is what you have on the row here. And in this case, that's the personal cost. And your column is what you have on the column here, which is the percentage increase in this case. Which is, sorry, I didn't do that. Personal cost, then percentage. So that's one use case for how you could use data tables and GOSIG. I'm going to try and see if we could take another example to simulate. Yes, maybe Monte Carlo simulation might help. So where you have a couple of experiments, but oftentimes it's usually going to be a one-way data table for Monte Carlo actually. But I mean, is this clear? Should we take another example, or should we move to scenario manager? Hello, can you hear me?
Yes, I think we
Yeah,
should.
I hear you.
Sorry, I didn't catch that.
I think we should take another example.
Okay, another example. So let me print So let me look for some data. Okay. 1 second, please. Can you see my screen, right?
Yes.
Okay, thank you. Let's assume that you want to, this is okay. I just went to download the stock data from, this is Unilever, for example. So let's assume you want to invest in, let me just copy this into the real sheet that we're doing so we can, so then I can put this clear. Let's assume this is the stock price, monthly stock price for this stock Unilever. So let's say you want to invest you want to buy the stock, and you're trying to say, okay, what is the percentage? What is the probability that I'm going to have maybe 20% increase in the value of my investment if I invest in this stock in the next 1 year? So typically people could simulate a couple of trials and then use that to get what it would be with data tables. And then this principle is pretty much some sort of Monte Carlo simulation where you're going to simulate a trial, and then you are going to then go seek. So you're going to run a data table on that trial for 1,000 trials or more. And then that gives you different possibilities that you can then model upon. And so because you are trying to get returns, you will have to calculate returns of the stock price, which is just percentage change. So we'll just do this divided by this -1. So that's the loss. Okay, so that's so I think this is about 10 years data. So
Sorry, how did you do that? How did you get the returns just now?
Is percent. So returns on stocks is just the price movement. So it's the percentage change of the current day or the current period over the previous period. So this is June. So it's June divided by me -1. It's pretty much saying this minus this divided by this. The way we do it in the traditional way. But when you put it into algebra, this will cancel this, right? The B3 and B3 will cancel themselves to give you 1. So that's why I'm just using B2 divided by B3 -1. So it's shorter than to write in formula than this one.
Okay.
And then from an algorithm point of view also, it saves Excel some very few space to run this if you're going to run a lot of it, for example. It's not so much of capacity on Excel, but still we can still make Excel more efficient. And it's pretty much straightforward. You don't have to put the arrow here. So because if you want to actually expand this now, it's going to be B2 divided by B3 minus B3 divided by B3, which is exactly the same thing. So, and then B3 divided by B3 is 1. So it's going to then be B2 divided by B3 -1. Sorry, that's B3 here. So that's exactly what we've done. It's simple.
Interesting. Okay.
Yeah. So,
IJ, this is levels.
I swear to God. Let's go on, I beg.
Yeah, so but oftentimes, if you're working with maybe SQL or you're doing a lot of analysis, one of those things that makes it complicated is when there are too many variables. So it's usually nice to first of all put those variables on paper and see which one can cancel out algebraically and you just discover that your SQL code really faster, and then there are not so many things you have to code. You're not going to have so many common table expressions because you have cancelled some variables because they will cancel out mathematically, and then it makes it easy for you to run. It's the
Thank
lazy
you,
analyst.
Idris.
It's the lazy analyst way of work. Okay, so what we have the returns. We want to simulate for the next 1 year. So if I'm going to put my money to buy Unilever stock and wait for 12 months before I sell them, what will be my return? So which means I have to simulate a 12-month stock price movement as a single trial, and then I will then run multiple simulations of that particular trial, multiple trials of that particular simulation, sorry. So again, I will say this is monthly data, right? So let's even put a month after it, months. So we could just say month 1. We'll just do month 1. So that's 10 years. The concept in real life is called bootstrapping. Bootstrapping allows you to use the past. So they use it a lot in the stock markets, especially before the advent of high frequency trading, to use the past to predict the future. So in bootstrapping, you assume that the stock price will move in a random way, like it has done in the last few years, maybe 5 or 10 years. So you're saying that the behavior of the stock price, a monthly or daily stock price, will not be different from what it has done in the past. So you can then use that concept to simulate a trial, and then have multiple trials, and then calculate a probability, and you get. And oftentimes, the larger your simulation, I mean, the number of simulation, it follows the law of large numbers, which is that you are going to get your mean return would be close to what it would have been in reality. And that's the concept, the statistics, and it makes it very, very easy to bet your money in the stock market and go to sleep, because I never fit. It hold way. I mean, this is assuming that the market is efficient. There's no Elon Musk talking about the stock, and there's no pandemic, so it assumes that, okay, life is normal, no issues. If there's no election around the corner, and we're fine. So to do that, because we are going to first simulate the next 12 months, so we can then have next 12 months. Okay. So the first month after this month was another 1 month. So that's the next 12 months. Because, and this is what we're doing the next 12 months. Because
it's coming out as if it's a Boolean, like it's in the center. Why is it centralized?
Because I made it so you can, because it's number. So if I make it, you can go to this way. You want it in accounting format.
Okay, no, it's fine. It's fine. It's fine. I was just curious. Okay.
I'm just doing it for aesthetics, so it looks appealing. Sorry.
All right.
The starting price. So the starting price is actually the price that it is currently selling at. The last price here is 14.95. So I could select it because I want to simulate the next 12 months. As I said, I want to keep my money in the stock market for the next 1 year, and I want to estimate what returns it would be. So it would give me. So if I'm fine with the returns, I can put my money. If I'm not, I can say, okay, no, maybe let me put it somewhere else. Or let me not put it in this Unilever stock. Let me go and buy another stock. So sometimes what people do is they could download 20 stocks, and then maybe weigh them, run this simulation, and then say, okay, if I have this amount of money, I'll put 30% on this, 20% on this, 5% on this, 10% on this, based on the risk and the return. And then they have a diversified portfolio, and then they go to sleep, and then they come back after 1 year, take their money, and then they go. Some could even do more than 1 year, they could do 5 years, and then they go. So, but that's when the world wasn't very volatile. I'm not sure people do that a lot, but it's still a very applicable concept when the world gets back to normal. So here, we need to simulate what will be the returns. We need to get what will be the end price for that month, so for the next 12 months. So the end price definitely would be our start price plus whatever our return is, which is this way. But to get our returns, we then need to run a random trial. So we can just simply say, just use run between, for example. Because our numbers here is between 1 to 120. So we can say 1 to 120. So this is the randomization. This is what makes it a simulation. And then we can run a quick VLOOKUP or an XLOOKUP on this 5 here from this month. And we want it to return the returns.
Sorry, Idris.
Yeah.
Not you are using XLOOKUP.
Yeah, we could use VLOOKUP. Anything. Which one should we use?
What is XLOOKUP?
Is the newest guy in town.
Okay.
It's been around for a few months, but you know, VLOOKUP has some limitations when you use them. You know, it allows you to your lookup value has to always be on the left, right? And then if you're working on very large array, you will have to then start counting how many columns, maybe 35. You're not going to do everything, you know. But XLOOKUP gives you that. XLOOKUP does the equivalent of index and match in one formula, in a very short formula, actually. So
please, can you show us how it's done again?
Yes, I will, definitely. So it's XLOOKUP. It's the way VLOOKUP is done, actually. That's what makes it interesting. In fact, when I read the preview, I was waiting for it to come out. That's how excited I was. So the first thing is, what's our lookup value, which is this 96, comma, then our lookup array. You know, so before in VLOOKUP, you're going to select everything. But in this way, you don't need to select them. You're just going to select the lookup array, where you are looking at that item for. So it could be this one, you know, so in this way. Or I just like to define the entire thing. So I'm going to have to do log the formulas and then comma. And then it's asking me for my return array. So my return array is, what am I returning? In this case, it is the return, right? And this one. And then comma. And then it also has another advantage it has is that it allows you to handle exceptions. So you know, when you write VLOOKUP before, when it is not there, VLOOKUP will return any, right? And then you now have to maybe have your report having any like that, or you put an if error or if any for the formula. XLOOKUP doesn't need that. XLOOKUP handles exception itself. So it's telling you, if you don't find it, what should I return? So I'm saying, okay, return 0. And then it's then going to ask you what kind of match. So you could do an exact match, a smaller than the larger item, which makes it very intuitive. You could use it to return an array. So if you want to do VLOOKUP where, you know, the way we do VLOOKUP where you want to return something smaller than an item in a table. So it also allows you to do that. So I think it's the perfect lookup formula in my own way. And then you could just, so I just leave this one blank. I don't worry about it. So for me, so it depends. So you could say not found if you don't want to find it but in your if not found, I just put 0, the way we do if we are trying to use if error on VLOOKUP. So again, your lookup array, your lookup value, then your lookup array, which is the month we're trying to check for, and then your return array, which is the return that we're looking for. And then it's saying, if you don't find it, what should you return? And what match do you want? So I want exact match, which if I do that again, exact match is 0. So I can select that, and then I'm good. So we could call this random month.
Guys, if you have any question, you can interrupt him.
Yes, please. Yes, please. So again, the concept is that if I want to simulate, I'm using the returns of the previous years to forecast the future in a random way. And that's why I've used the random number here. So I can drag my random number down, and then I can drag my return formula down. And then oftentimes the starting price of a stock is the ending price of a new month, is the ending price of the previous month, right? So you just do it this way. And then your same the formula we had here, you put it down, and then you could just go to the end. So once you have this, you have done a simulation. So this is one trial. This trial is saying that at the end of 1 year, the ending price, if I put my money in the market, is 14.91, even though I'm starting with 14.95. But this is one trial, right? This is one trial. I can have multiple trials by pressing F9. So I can start pressing F9 and then it will change. It will change. But I don't want to do that. I want to put it in a table to do 1,000 trials and then get my results. So again, the concept is, what is the probability that I'm going to get good return in the next 1 year if I put my money in this stock? You could use linear regression, right? And say, okay, but stock price do not move in that manner. They move in a sort of a random fashion. So because of that, oftentimes people use this technique called bootstrapping, where you are going to assume that the next 1 year is similar to any of the scenarios in the last period that you have selected, in the last 5 years, last 10 years. So how do you do that? You're just going to create a random number here and then say, okay, give me the returns on any of this month, and then I'll use that. But this is the trial. This is one trial. So you can then use data table to have multiple trials. So I can then, this is my price. This is the price at the end. This is the starting price. So my return in the next 1 year is going to be, so I would call it next 12 months return. I would be by this one divided by this one minus 1, as we have done before. So because it's a trial, so it's going to continuously move. So it's not going to be a fixed number. And then I can have 1,000 simulations. So I can just say, I think there is a formula called sequence. So I can have 1,000 rows. So I can use this to have 1,000 items.
Yes, can you do that again? Can you show
Yes.
that again? How you got that
Yes.
1,000 rows, please?
So there's a formula called sequence. Sequence. So sequence is asking you, how many items do you want? So I want 1,000 rows.
Okay.
No column, so I'll leave it blank. I'm going to start from 1. And how many steps? 1 step.
Okay, so it can be 5.
Yes, so we could do,
yeah,
so let's we could do that again.
Okay.
So sequence. If I say 10,000, 1,000 rows again, sorry, no column, start at 5 and give me every 10 steps.
10, okay.
It's going to, no, okay, yes.
Oh, you put
So
double. Oh, okay,
yes,
okay. Wow, okay.
So that's how it works. So for us, because we need 1,000 trials, so sequence 1,000.
No column.
No column, sorry.
1
and 1 step.
Okay, okay.
So that will change it. So, and then you could just run a one-way data table here. Remember that our result is on the column, right? And so we are going to leave the row and AWT again. Leave the row, go to the column, and then we'll select. So for this one, you are just going to select anything outside of the cell, any empty cell, and it's going to. That's the beauty about Monte Carlo simulation. So you now have, so what you have done is you have simulated 1,000 trials of what you've done here. So all of what you've done here is one trial, which gave us this minus 6%, I think, minus 7%. So what we did at table, I've done several of it. I've done 1,000 of the same thing. And because it's a random experiment, for every time it runs different experiments. So this one trial is saying I'm going to have negative, but we know that that's not the case. So we can then have 1,000 trials or 10,000 trials and then see what is the probability of having our percentage. So if I want to get 10%, for example, 10%, I want to than 10%. I will just first, our total is 1,000. We did 1,000 simulation. So we could pretty much use a count if, or a count if to see from this range, how many of them have above 1,000 or above 10%. And I can then just do percentage of it. So there's about 36% chance that if I invest in Unilever using their stock data in the last 10 years as a basis, assuming that the world is perfect, in the next 1 year, if I just go and sleep, there is 36% probability that my investment would have increased by 10%. This is exactly what we've done with randomization, with data tables, and with bootstrapping. So that's another use case. There are several use cases for how you use data tables, but effectively it allows you to have multiple scenarios. Allows you, so if instead of me having to do this 1,000 times, I'll just do it once and then I'll redo it 1,000 times. So I would try to re-explain the entire concept again, and then I will address questions if you have any. Or should I take questions first and then I'll revise?
Revise before questions, Idris.
Thank you. So again, we got the dates, we got the stock price.
Thank you.
We got the dates, we got the stock price, and then we just try to flag a month rate, and we calculated the return. And I said that it's the best way to calculate percentage change is just the new divided by the old minus 1, as opposed to have to spend time to do the bracket. It's the same thing. And then you could drag down. So the question was, we want to get what would be the possibility of having more than 10%.
Hi, Idris.
Yes, please.
Sorry to interrupt, please. Thank you for this. I have a question. The sequence.
Yes.
I think I missed a step, but I just want to find out, is it the same as fill series? So maybe as I want to understand.
Yeah. You
okay.
Could,
okay.
Yeah.
I could use fill series. Okay, thank you.
Yes, you could. Okay, so the question is, if I have some free cash and I want to invest in the stock market and I want to get 10% in the next 1 year, so I can pick several stocks and see which one will give me that. So based on the probability of it, if I have 40% or 30% probability, I'll put my money. If I don't, I will move on. Or so we could use this technique to use it to simulate what each single trial, and then use data tables to have 1,000 trials, and then estimate our probabilities on that. So just the probability of greater than this one here. So what we did was, the next 12 months, we simulated that, and then we got the starting price, which is the end price of the last month here in June. And we said on this one, you're just going to do a randomization, just put rank between 1 and 120. 1 and 120 being that there are 120 months here that we selected. And we calculate our returns using XLOOKUP. So, and I said XLOOKUP is the new guy in town, allows you to handle exceptions that VLOOKUP does not handle, that you have to use an if any or if error for. It allows you to get the benefit of of index match without having to run a long index match formula. And he also covers all of the flaws that VLOOKUP would have. So my lookup array can be anywhere, you know. So if I had moved this month from B to E, if it was in E, for example, here, my VLOOKUP wouldn't have returned a value. I would have to first rearrange my data to use VLOOKUP. But this one, it doesn't matter. It could be anywhere. You could even use it on row, on columns, doesn't matter. So it does VLOOKUP, HLOOKUP, index match, everything together. This formula does everything. So, and I said the easiest way is just XLOOKUP, the value we want to try and get, the lookup value, where are we looking at it from? And what are we returning? The array. And it's asking us, if we don't find it, what should we do? I said, okay, put 0. So I've handled the exception already. I've handled the error that would have come. And then I said, I want exact match. And I close the bracket. And that's it. And then you calculate your new price, which is just, is like calculating percentage increase. So is your starting price times 1 plus what the return is. And then you drag down. And I said your end price, your starting price for the new month is the end price for the previous month. And then you drag down. And based on this one trial, the price for the next 12 month return is actually the end price in the next 12 months and the start price for the first month of the next 12 months -1, just as we did for the return. So he has calculated for next 1 year. But this is one trial. So I want to use that table to simulate 1,000 trials. You know, that's the concept around Monte Carlo simulation. It allows you to do several trials and then calculate probabilities that could give you results. So you could even calculate mean returns here. So if you want to see what the average returns would have been, it's 5%. You know, so and that's the entire concept around. So this is one use case of how you use that table. So do we have any questions?
I think we are fine.
Okay, thank you. So should we go to scenario managers, or we think this is quite enough? Okay, so should we go to scenario managers? Okay, so unlike GoSeek, as we have said here, that allows you to have you only check one variable and see what you can only arrive at a result with one variable only. You can't see other options. With data tables, you can see multiple scenarios, as we've done with our guy that wanted $40,000. And then for scenario manager, it's a bit different, you know. So it allows you to. So there are several use cases. So if you're needing your budget, for example, you could use it. If you want to set prices as well, you could use it. So if, for example, you have your sales team telling you that these are the range of prices. You know, let me try and do something. These are the range of prices that will give you the demand. So let's say we sell computers, or maybe we produce and sell something. You know, let me try and we just sell, and then let's assume we sell at maybe $50. And at $50, our sales team has said that the demand would be around, let's say 4,000. You know, and again, the person said, okay, if we sell at let's say $51. The demand would drop. So the higher the price, the higher the demand. Demand would drop by maybe 3%. So so let's assume that we have our demand elasticity at maybe 2. Let's leave it at 2. So in demand elasticity, it's like if you increase your price by 1%, your demand will drop by 2%. That's what it means. So if I increase my price by 5%, my demand will drop by 10%. That's what it means. So that's the elasticity. So if we increase our price by 1, let's say we did this by times 1 plus 1%, our price will drop, our demand will drop by 2%. That's what the elasticity of demand means. 1 minus 2%. So and then we can continue dragging it down. So, but let's then assume that you want to, maybe it cost us. You need cost of this item. So this is selling price. Let's say it cost us $25 to produce, sorry. And we want to know what is the price that we will sell that would maximize our profits. So you would use scenario manager in this case. So oftentimes, the fact that you cannot just put your price at 50 and say, okay, if I put at 50 and I sell 4,000, I'm okay. Or no, I want to make more profit, and I want to sell at 55, 51, and I'll sell less, but I'll still make my profit. So oftentimes it is usually nice to look at it mathematically and say, what price can I sell this item that we are selling that will give us the highest profit? Oftentimes the price might not be the highest price. It might not also not be the price at the highest demand. It's usually one way, somewhere in between. So you could use scenario manager to actually get that, and that's the use case we are going to use. But to do that, we need to get a demand equation, pretty much. So a demand equation here would be our dy/dx on price and demand, which we can actually get from charts. So we go to the example charts, and we use the scatter chart, which is what's that? Interesting. No, sorry. It's not. Let me switch the way the data is coming. Transpose it. Okay, so this is how I'd expect it to look. So I can. Okay, so if I do it this way now, I think. Okay. Scatter. Aha, so this is how it will look. So this is the typical demand curve, right? So the higher the price, the lower the quantity demanded. So with this, we can just go to trend line, linear, or more options effectively, and then add an equation. So this becomes our regression equation that we can use to sell. So we can, where our y, of course, is demand, and our x is price. So with that equation, we can determine what is the best price we can sell. So if, for example, we know what's the best price we can sell at that demand, so that's how to look at it. So let me write out the equation y is equal to 12,000 minus 160x. Okay, so that's so if we want to get the price that gives us the best profits, we just need to estimate what that would be effectively. So if we say our price is 50 and the demand at that price is 4,000, and we know it cost us 25 just from here. Then our profit is actually the demand times what we sell minus what we. This is our profit at this amount, but it doesn't mean that's the highest profit. So we can actually get a maximum demand, a maximum profit that will give us the best demand at a particular price. So especially if we have capacity to produce more than 4,000. So to do that, we just go to scenario data, what if analysis, scenario manager. Come in 1 sec. 1 second. Sorry, 1 second. Trying to check something. Okay. So again, one of those things you do with scenario manager is you have to so you will have to create a scenario name. So let me just call it Idris. And one second, please. Sorry, I'm coming. Something isn't right. I'm trying to check something. I'm coming 1 second. Sorry, give me a second. Okay, so yeah, I think I got what the issue was. Slightly apologize. Okay, yeah. So this is so I think I got it mixed up again. So we cannot apply this use case for scenario manager. You apply this use case if you are using Solver. So I was trying to wonder what happened. So it allows you to set your price. So I'll just try to do this and then we can go to scenario manager. I'll take it some other time. So again, as I was trying to explain, so we can determine what is the highest profit there by using the solver. The solver is under data analysis. and we want to get the highest price by changing the price. I'll take that again. I just want to show us how it's solved. And then it's solved for the highest. Okay, it's coming to the side. So let's go. It's like I'm having an issue with there's, yes, that's how it should be. So we can scrap this use case for solver and then try to look at something as a scenario manager. But this is that's actually what I thought, but I think I mixed it up. Sorry. So I was mixing up the solver with the scenario manager in the use case. So I will have to think of a new use case for a scenario manager as opposed to using the solver here. So apologies, I can't think of any for now. I had the use cases in my head before the class, trying to think if I could think of something for the scenario manager, because it allows you to it's a bit more complex than your data table, so it allows you to build multiple scenarios, and I sort of mix it up, sort of. So let me see. I think of a complex use case. Okay, so perhaps we could take that some of the time, or maybe if I have something, I'll just work it into the Excel and I'll share. So, but essentially, this would have actually this was actually been the case for solver to actually determine the profit maximizing price. I also need to check what exactly is the reason why it's not. I think I know what this is. Okay, I think I know why this is the case. So this would have been 12,000. Sorry. You know, 160 times with the cost. That's weird. So effectively, it's saying that if I sell at 45, okay, if I sell at 52. So actually, the 50 is still the profit maximizing price in this case. So because if I sell at 52, it's 99. If I sell at 51, 99. If I sell at 49, it's 99. If I sell at 50, it's 100. Okay, so that's why it looks like it's not moving. So apparently, the 50 that I selected here was actually the maximizing price. So that's exactly why I have. So let me just try. So what if it cost? What is the unit cost of 20? Okay, so if I do 49. Okay, so that makes sense too. Okay, we could solve now. Okay, that works. Okay, so I apologize. So what happened was the price I had there was the profit maximizing price for that scenario, and that's why it looks like the number wasn't moving. And so when I change the unit cost now, let's say it costs $20, and this is the equation which I had applied to get the demand here. I didn't put that in the first place. So effectively, even though the demand at 50 was 4,000, it wasn't giving us the highest price. So we're the highest profit. So if the seller could go down to 47.5, I could get additional demand, which would give more profit than if they sold at 50. So that's the use case for solver, not for scenario manager, but it allows you to do pretty much similar things that you would do with the other what if analysis, but in a different way, not like the scenario manager. For the scenario manager, I can think of a use case and put in this Excel, and then I'll share.
Okay, Idris, thank you so much. Really, I've learned so much from today's class. Thank you.
And thank you for listening as well. Apologies, we couldn't take the scenario manager. Right, I sort of missed up the use cases, and then now thinking through it, say that it's not going to be an easy thing to think. I don't want to run through the same challenge I ran through here.
Okay, there's something I tried. Is it possible, maybe because of the equation, is it possible that if you had used the power demand equation, that would maybe make it different, and then set your objective instead of profit to be price? Sorry, instead of price to be profit.
Yeah, I think that could, well, no, I don't think that could also work. And that's going to give, that's if you have, and that's a different equation entirely. You could have similar results, but the challenge we had here was that I did not use this equation here in the first place. I just put the 4,000, so it wasn't working. And it was yeah. So the ones it was when I actually now used it and then changed the unit cost that the scenario. So and that's exactly. I apologize for that. But thanks. That's quite noted as well.
Thank you. I'll reach out to you privately if I do have any challenges, please.
Sure.
All right.
Sure.
Thank you, Idris. Thank you so much for your time.
You're welcome.
I'm truly grateful. All right.
You're welcome. Yeah. Thank you all for listening. And,
okay.
Okay. Thank you so much, Idris.
Thank you.
Okay, bye. Have a nice moment ahead.
Thank you.